Hey guys, this is an example video for increasing and decreasing functions in the first derivative test. I actually got a few questions about this, so I wanted to make a video with this kind of more specific example. So it's going to be the same type of exercise I've been doing in some of these other videos. So we want to identify critical points, find the intervals of increasing and decreasing, identify max, min, all that good stuff. So here's the function. So anytime you see stuff with rational exponents, it's probably going to get a little gnarly with the derivatives and finding the critical points. So first things first, I want to just kind of go through all the algebra on this and kind of everything that we need to know. Let's just note what is the domain, maybe before we get this party started. So the domain is just going to be all real numbers, so that's a good thing to note. And now let's go ahead and take the first derivative. If you want to pause and do that, go for it, hit play when you're ready. So let's see, this is going to be negative 6 times 6 over 5 x to the 1/5 plus 3 times 2 over 5 times x to the negative 3 over 5. Okay, so there are a lot of different ways that you can now deal with this situation. And in one video, I like to personally factor things out, so I'll show you that, but I'll show you another way, and you choose the way that you like best. So first things first, obviously I got to multiply all this stuff together, right? So I've got negative 35 or negative 36 over 5 x to the 1/5 plus 6 over 5 x to the negative 3 over 5. Now, what I've seen a lot of people do is they actually rewrite all of this and they try to get like one fraction. So for instance, this is a negative exponent, so I can rewrite this with a negative exponent. So I'm gonna be doing a ton of just heavy lifting algebra here to kind of help you get to the idea behind this. And you are totally gonna have to get your hands dirty with the algebra here. That is totally normal. Okay, so I have this. So in way one of this, just notice you really can't do anything at this point, right? Like you're gonna have to do something with this. So one way that you can deal with this is to turn this into a fraction with a common denominator, which this is pretty darn close, right? So these both have a 5 in the denominator. Just now the only thing that I would have to do is multiply this by 3 over 5. So why don't we just do that? So I will make this negative 36 x to the 1/5, and then I'm going to multiply this also by x to the 3/5 plus 6. And all of this now is going to be over 5x to the 3 over 5. So just making sure you've got that. So I'm multiplying this whole thing top and bottom by x to the 3 over 5. So you can just see the 3's over 5's. And I wanted to break out this detail just so you can see what I'm doing with the exponents. So now I have to add up the exponents here. So I'm already running out of room. So like I said, you really are going to get your hands dirty with the algebra here. Let me clear some space. Okay, so now I'm going to go ahead and finish this. So this is negative 36x to the 4/5 plus 6 over 5x to the 3/5. Maybe I'll try to make this as 3/5. Okay. So now what I can do is I can identify the critical points from this. So obviously there's a critical point. This will not exist at 0. So maybe I'll just write that here. So there's a critical point at x equals 0. And I'm just going to mention here this does not exist. But it does exist in the actual function itself, right? So this is kind of an interesting, when this happens, weird things happen with graphs. And you'll see that as we kind of go along in other problems. But I'll just tell you now, something weird will happen. And then now we got to focus on the top and set it equal to 0. So maybe you want to just see if you can now solve this and then hit play when you think you've got it. So if I look at this, so let's see, I get x over 4/5. This will equal now 6 over 36 is what that would become. And then I can actually rewrite this as 1 over 6. That's how it would simplify. And so now I've got to really take each side. How do I get this by itself? So now I'm just going to take each side to the 5 over 4, like so. So you're going to have to get a calculator to help you with this. Now, there's a few distinctions with this calculation that you still have to be careful with, by the way. So you're taking the fourth root of this. So the fourth root, kind of like the square root, just to kind of make sense of why this works. So forget about this for a second. Just think about something like x squared equals 9. What are the two solutions to this? Well, it's x equals plus or minus 3, right? So either one of these, if you square either one of these, then you will get positive 9, because negative 3 times negative 3 is positive 9. So it's the same deal. Actually, by taking this fourth root, this to the 5/4, you actually have that same positive negative relationship. So this side is going to be plus or minus. So there's one little plot twist. Now, okay, so there's actually like a lot of algebra even kind of baked into this step here. So I want to kind of show you all the different ways that this can work itself out now. So let's say, first of all, this is going to be x to the 4/5. This will simplify to 1/6. Okay, so to get x by itself, I want to take each side to the 5/4. But be careful with this, because when you take the fourth root of this, this is actually going to be plus or minus the plus or minus 1/6 to the 5/4. And why is that? Okay, so first of all, let's look at a way easier example just to make sure you get it. So if I assign like x squared equals 9, so you would use this, what's known as the square root property, to solve this. If you totally forgot what this is, I will actually drop a link to this in the comments. I just made a video on this, so you can watch more there. But the two solutions to this particular thing would be x equals 3 or x equals negative 3. So the whole idea behind the square root property is since you're squaring this, the way you'd solve this would be x equals plus or minus the square root of 9. And remember, the square root of 9 is really the same thing as taking 9 to the 1/2. So now instead of taking this to the 1/2, I'm taking this, going back here, to the 5/4. So this has got to be plus or minus. Okay, so now can we just take a second to kind of appreciate what's about to happen here? So let me clear some space. So I've got x equals plus or minus 1/6 to the 5/4. So depending on kind of what's going on, if you have to rationalize this, this can be a bit of a bear. So ideally you could just plug it into a calculator and get the decimal value. But let me also just show you how this would work if you have to actually rationalize this. So first of all, the top part, this is just going to be plus or minus 1 on top, right? So really, it's going to be 6 to the 5/4 that we have to worry about. So let's write 5/4 in radical notation. So that would look like this. So there it is in radical notation. Now, notice that the exponent here is bigger than this index here, so you can actually simplify this. I have a video on how to do this too if you just need a refresher, so I'll drop a link to that as well in the comments. So hold on to your hats here. This is going to be plus or minus. So this now will become the fourth root. So 6 times the fourth root of 6. So now I want to rationalize this. So to rationalize this, what I'd have to do is I'd have to multiply the top and bottom by not just the fourth root of 6. What you need are, in total, 4 powers of 6 to rationalize. You only have 1 power of 6 as it is. So I actually need 3 more powers of 6. So this is actually what I have to multiply by on top and on bottom. So now if I work all this out, this becomes plus or minus. So this I could rewrite as 6 to the 3/4. So I just rewrote this top part as 6 to the 3/4. And then the bottom, this becomes 6 times the fourth root of 6 to the 4th. Now in doing this, the fourth root will cancel this out. So now I'm going to continue on over here. This will be plus or minus 6 to the 3/4 over 6 times 6, which is plus or minus 6 to the 3/4 over 36. So some books, systems might actually go through all this. So there's a lot of work that actually goes into that. Like I said, ideally you could just say that this is the decimal. And that decimal is going to be just plus or minus. So you have to obviously round. This is like some crazy decimal. but this would be 0.1065, so I went to 4 digits. But it just depends on the context of what you're being asked. So you might want to use the decimal, or you might have to answer this. It just kind of depends. Okay, so that is one way that you can solve this whole crazy thing. And if I may, I would like to also show you one other way that you can do this. So let me just note that other critical point that I just found. So that was this plus or minus 0.1065. So what I want to do actually is I want to take, I want to go back to the first derivative, and I just want to show you the other way that you can do this, just so you kind of know. So let me make some space. So now I'm kicking it back to the first form of the derivative before we went with the whole, getting the common denominator. So the other way that you can do this is you can factor out stuff, which is, that's kind of the way I like to do it, but to each his own. So I want to factor out the negative exponent, so I want to factor this out. And then I also want to factor out this fraction. So notice if I factor out 6/5, it will just happen to work out that this will become a whole number when I factor this out. So if I factor this out, just to show you the other way you can do this, I'm going to factor out 6 over 5x to the negative 3/5. And then this will become negative 6x to the 4/5 plus 1. So that's how this would kind of factor out. And I personally like this just because then, when I look at this factor, I can see that this definitely can't be 0. Then I can set this one equal to 0. You'll get the same critical point as before. So like I said, it's 6 one way, half a dozen the other. A lot of people I know don't like factoring things out. They like having this kind of crazy looking thing. Personally, I don't like having kind of all these fractions. I like seeing the factors, but you do you. Okay, so I've finally got all my critical points. Great. And so now let me clear some space and let's talk maybe increasing, decreasing, all that good stuff. Okay, so I've made myself some room. So now we can construct our table. So we know what our intervals should look like, and we can figure all this out. So if you want to pause the video here and then hit play when you're ready, go for it. And I kind of cut off the decimal a little bit when I did that, but that allowed me to at least get everything in this table. So now we can go ahead and start figuring out kind of the signs of everything. So if you plug in something, say, let's put in something like -1, the bottom will end up being negative for sure when you plug that in, and then the top. So remember, when you plug -1 into this, because this is 4 over 5, that's actually going to turn the -1 into a +1. So this will just be -36 plus 6. So this is a negative over a negative, which will make this a positive. Okay, and then moving on to this next interval. So I'm still going to have something negative over something negative. So this will end up being still positive. And then when you move on to this interval, so if you plug something in here, so now this will be something positive, so the bottom will now be positive. You'd have to actually plug in a test point probably to figure out what's actually happening here, but if you plug in something between just like say 0.1 or whatever, this is something positive or something positive, so this also is positive. And then in this last interval, so then that will turn this into something negative over something positive, so then the bottom will end up, so the whole thing will end up negative. So you're gonna have to play around with some test points for sure for this. These are not easy numbers. You might actually have to like go through and calculate some of these things out. And now you can see as far as just like what your max and mins are actually. So these points here indicate that we just have increasing, 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 and then from here we have increasing to decreasing. So what that tells me then is that at least here I have a maximum. So we will just say that, you're increasing on all these, decreasing here, and then you can say that this crazy number, which I wrote back in that crazy rationalized form, that's a local max. So definitely not like one of the easier examples. So thanks for submitting that to me, guys. Okay, so that'll cover it for this one. So hopefully that was very helpful. I know there's a lot of heavy lifting with algebra, but hopefully that was helpful to you. I'll see you guys next time.